Hey, have you ever wondered how apps deliver live updates from chat messages to stock tickers? In this video, we will break down the major real time communication standards that power those experiences: polling, server sent events, WebSockets, and webhooks. We will not only explain how each of these works but also compare them side by side so that you can understand when to use which approach. Whether you are building a chat app, a live dashboard, or integrating with external services, we will cover all of it. By the end, you will have a clear roadmap of the tools available for real time communication and how they fit into the modern web development and other fields. So, let's jump in. Most of the web runs on HTTP protocol, the classic request and response model. The browser asks for something, the server replies, and the connection closes. Deal done. That's great for loading pages or submitting forms, but not so great when you need live updates or two-way communication. For things like real-time file transfer or instant sync, we need something more persistent. Developers have tried to work around HTTP's limitation using polling. In short, polling, the client keeps asking the server, like, hey, anything new? Any updates? Which wastes bandwidth and server resources as well. Long polling is a bit smarter, where the client asks once and waits until the server has something to say. It's better, but still relies on repeated reconnections and isn't really real time. So WebSockets solve this problem. They start as an HTTP request initially, but then upgrade to a persistent TCP connection. That means that both the client and the server can send data whenever they want. There is no need to wait for a request. It is full duplex, low latency. Modern messaging protocols like WebSockets, Apache Kafka, and RabbitMQ are the backbone of real-time systems. They are fast, they are reliable, and language agnostic. Now you might be wondering why WebSockets? Why not Kafka or RabbitMQ? They are powerful, they are scalable, and they are great for production systems. But they also come with setup overheads, routers, queues, deployment complexities, brokers. Now let's talk about Storm. Storm is simple text oriented messaging protocol. Think of it as a tiny standard that sits on top of our WebSocket connection and turns that raw socket into a lightweight message bus. Instead of sending arbitrary bytes and inventing your own rules, Storm gives you frames like connect, send, and subscribe, so both the client and server speaks the same language. This is especially useful in Spring because Spring messaging maps Storm frames directly to controller methods or endpoints. So you get readable messages, topic-based routing, and an easy part to add broker-backed durability later. Server sent events is a simple yet clever HTTP native way of real time communication. In SSE, the server pushes text events to client or the browser on a single long lived connection. By HTTP native, I mean to say that SSE works over HTTP protocol itself. There is basically no need to set up a new protocol or a WebSocket. A request is sent from the client, and the server keeps sending data over the same connection back to the client. Many LLM powered systems like OpenAI's Streaming Responses API use SSE styled streaming so that the generated response text is sent to the client in incremental chunks, which helps the browser create a progressive typing experience for the user. This is what you typically see while using ChatGPT. The response doesn't all come at once, but little by little. Let's look more closely at the flow as to how the entire thing works. First, the user sends a prompt. There is a simple HTTP post request sent over to the client, and the backend receives this request and calls the LLM in streaming mode. LLM starts sending the response in a token by token or in small chunks. Then the backend starts converting server sent events from these tokens or chunks in a specific format. Then every event is flushed so that the client or the browser can receive it instantly. In browser, the event source connection is opened. As the events come, they are received and appended in the UI. This creates a dynamic typing effect. When the response from the LLM is complete, a final server sent event is sent by the backend, which basically tells the client that the event stream has now ended and then the connection is closed. The main advantage of for SSE is that the user get response and UX is smooth as ever. Let's see some more of benefits of the LLM streaming from user experience point of view. The first point over here would be low perceived latency. So perceived latency means the amount of time that user feels like the response time is. For example, if the actual latency is 2 seconds, but if the response starts coming instantly, so it feels like the system is really, really fast. If the partial response is delivered instantly, so waiting time appears less or even negligible. Then second point is better engagement. The progressing typing effect achieved here makes the conversation feel more natural and user feels more engaged in it. Then there is partial actions. On the client end, you choose to stop the response in between. This is called early stopping and it can be used for moderation or summarization without waiting or to receive the entire response. Then LLM backend teams can implement logging, monitoring, real-time feedback and with each token because this data is actually crucial for them to improve their systems. अभी हम कंपेयर करेंगे कुछ बैचिंग स्ट्रेटजीज फॉर एसएससी टोकन स्ट्रीमिंग के लिए। जब आप एसएससी स्ट्रीम कर रहे हो तो आप हर टोकन भेज सकते हो या थोड़ा बफर करके बैच में भेज सकते हो। तो पहला हमारा आता है पर टोकन स्ट्रीमिंग। सो इट सेंड्स टोकन इमीडिएटली एज इट्स जनरेटेड एंड अल्ट्रा रिस्पॉन्सिव फील आता है लाइव टाइपिंग जैसा। हाई नेटवर्क ओवरहेड ड्यू टू फ्रीक्वेंट फ्लशेस। इट इज़ आइडियल फॉर परसीव्ड लेटेंसी बेनिफिट। सेकेंड हमारा आता है फिक्स्ड साइज बैचिंग। सो इट बेसिकली ग्रुप्स अ फिक्स्ड नंबर ऑफ टोकन्स, फॉर एग्जाम्पल लाइक 5 tokens or 50 tokens before sending. Then this actually reduces network calls and improves throughput. ऑल्सो इसमें थोड़ा सा डिले इंट्रोड्यूस किया जाता है बिफोर फर्स्ट विजिबल आउटपुट. इट कैन फील चॉपी इफ द बैच साइज इज इन ट्यून्ड वेल. देन थर्ड पॉइंट है हमारा टाइम विंडोड बैचिंग. सो इसमें टोकन्स भेजे जाते हैं एक पर्टिकुलर रेगुलर इंटरवल पे. फॉर एग्जाम्पल एवरी 500 मिली सेकेंड्स पे एक टोकन्स भेजे जा रहे हैं, एक बैच भेजा जा रहा है. इट्स स्मूथ पेसिंग विद प्रिडिक्टेबल यूएक्स. So it is good for actually the front end people, or you can say when you are handling the front end of an LLM output, it is particularly good there. Then after empty batches भी भेजे जा सकते हैं अगर tokens ready ना हो. Also, it requires careful tuning to balance speed and efficiency. Then there is fourth point, which is adaptive batching. डायनामिकली एडजस्ट किया जाता है बैच साइज को या टाइमिंग को टोकन रेट या लेटेंसी के अकॉर्डिंग. इट बैलेंसेस रिस्पॉन्सिवनेस और परफॉर्मेंस, ऑफर्स बेस्ट यूएक्स व्हेन डन राइट. इट इज़ बेसिकली थोड़ा सा और ज़्यादा कम्प्लेक्स होता है इम्प्लीमेंट करने में और डीबग करने में. So other than APIs, webhooks are one of the simplest yet most powerful way to make applications talk to each other. Instead of constantly checking for updates, webhooks let external services talk to each other and notify your system about the moment something important happens, something that in terms will be known as event. So what are webhooks? Webhooks are basically a way of communication between two systems wherein one system is going to automatically notify another when something important occurs. Instead of waiting for you to ask, the service sends a message directly to your endpoint the moment an event occurs. Think of it as a push mechanism which is fast, efficient, and event driven. They are widely used for things like payment confirmations, user signups, or status updates. because they cut out the need for constant checking. And whenever these events occur, they just push a message or the event to another system. Now let's try to understand webhooks with a simple analogy. So suppose there are two castles A and B with a rift between them. Whenever castle A needs to send a message to castle B for help or other reasons, someone would have to go around and inform someone in castle B. But people in castle A found a better, efficient way of sending messages. So they installed a catapult on their end and they added letters or parchment paper to the stone and use it to send messages to castle B over the rift. In this example, the castles are basically systems talking to each other. The catapult is the webhook endpoint, and the stone with the letter is the payload, and the trajectory represents the API call made. So, when an event happens, the system A pushed it over an API call to system B. A webhook is like a digital messenger. At the heart of it, there are two key players, the webhook provider and the webhook consumer. The provider is the system where the event happens, like a payment gateway, a user sign up service, or a form submission tool. When something important occurs, the provider sends a message, an HTTP post request to a predefined URL. The URL belongs to the consumer. The webhook consumer is your application waiting to receive that message. It's like a listener or a doorbell. When the provider rings it, your app wakes up and processes the data. APIs are all about request and responses. Your system calls an API when it needs information, and other system replies. With webhooks, the flow is reversed. The other system calls you when it has something new to share. APIs are great for on-demand data, but webhooks shine when you want instant updates without having to ask every single time for it. So a lot of people get confused between long form of polling and webhooks. Long polling is a technique where your system sends a request to another server and waits sometime for several seconds until there is new data to return. If nothing happens, the server holds the connection open, then eventually replies with nothing. Your system then repeats the process again and again. It is better than basic polling because it reduces the number of requests, but it still relies on your system constantly asking for updates. Webhook flips the model. Instead of asking, your system sets up a listener, which is an endpoint, and the external service sends a message the moment something important happens. There is no waiting, no repeated requests, just instant delivery. Server sent events create a one way stream from server to the client, sending updates continuously over a single connection. So, how are these different from webhooks? Well, SSEs are great for live feed or dashboards. Webhook, on the other hand, are discrete messages. Each event triggers a new request to your endpoint. SSE are about ongoing streams, while webhook are basically about individual notifications. WebSocket establish a two-way persistent connection between client and server. They are perfect for chat apps, multiplayer games, or anything that needs constant back and forth communication. Webhooks don't keep a connection open. They are one-off, call triggered by events. If you need lightweight event-based notifications, webhooks are ideal. If you need continuous interactive communication, WebSockets are the better fit for it.